Hi guys, and welcome to the video for this week. We're doing something special because we're doing applications of area and circumference. So you get to see me working through these problems face to face, and I hope that you learn something good from this. So let's get started. As usual, we're doing the same thing as we did before. Be able to calculate the circumference or area of a circle. Circumference, remember, is the physical distance around a circle. And area is the distance that it covers. And then we're going to know we're successful when we can find the area circumference, work backwards, and we're going to be able to apply this to real life situations. So remember that the circumference is the perimeter of the circle measured by calculating the diameter times pi. So remember that the formula for that is the circumference is equal to the diameter times pi. And the area is equal to r squared times pi as well. And then don't forget about the difference between approximate and exact answers. Remember that the exact answer should look like 12 pi, and then its equivalent answer would be close to 30. It would be like 37 point something. So I'm actually going to pull out my calculator here, as you can see, and multiply 12 times pi, and that's 37.70 when it is rounded. All right. So the next thing I want to talk about is sectioning of circles. So when we talk about circles, we can split them into parts based on the angles that create the section. We take the degree measure and divide by 360 and use it to figure out what portion, like what fraction of the circle that we have. So in this example here, I have 120 degrees of the circle as this section, meaning that this section would be 240 degrees. So the 120 divided by 360 would equal 1/3. So I have 1/3 of the circle. I have 1/3 of the circle. That is the section that I am talking about here with the 120. If I did the other section, 240 divided by 360, that 240 divided by 360 would simplify as a fraction to 2/3, and it would represent a section that is 2/3 of the circle. So let's just keep that in mind as we work through some of our problems here. So, word problem example. A pizza slice has a measurement of 8.5 inches from center to crust. What is the circumference of the pizza that it was taken from? So normally, guys, when places like Domino's, places like Pizza Hut, remember that no one out-pizzas the Hut, when they do their pizza measurements, they're giving you the diameter of the pizza. This would be a 17-inch pizza is what they would call it. And so if I go ahead and fill in what I know, an 8.5 inch measurement from the center to the crust. What is the circumference of the pizza? Well, to get the diameter, we would have an 8.5 inches over here as well. So if you added these two together, you would get that you have a diameter equal to 17 inches. So to calculate the circumference of that, I'm just going to use the formula of the circumference is equal to the diameter times pi. So filling in what I know, I would put in 17 times pi. And that would be my exact answer right here. But when we interpret real-world situations, a lot of times we use an approximate answer because it's tough to tell somebody, hey, the pizza has a 17 pi inch circumference. If you told them it was about 51 or 52 inches, that would be a lot more understandable to someone. So we're going to go ahead and type in 17 pi on the calculator. And the approximate answer, and I'm going to use the squiggly equal sign to indicate that it's an approximate answer, is 53.4 inches. And that's the approximate answer. So, moving on. A circular racetrack has a diameter of half of a mile. How far does a race car travel when it completes a lap? Okay, so if I draw in a diameter, according to the problem, I know that this is 0.5 miles. And so I'm going to, again, interpret how far does it travel. The word far would indicate distance. And then distance when it completes a lap, I would interpret that as distance around. And so the phrase, I'm going to check to see that my text is the right size. The phrase distance around would be like perimeter, or that leads me to know that that's circumference. So I'm definitely dealing with a circumference problem here. And so I'm going to be using the formula C is equal to the diameter times pi. So I'm just going to plug in 0.5 for the diameter times pi. And half of pi, if that's the exact answer, by the way, would be 1/2 pi miles. But the approximate answer, and because again, it would be something that when you communicate with people, you probably wouldn't tell someone that you go 0.5 pi miles. You would tell them that it's approximately 1.57 miles. And that's if the racetrack was perfectly circular. Most racetracks, if you've ever watched racing, are like ovals, or they have like straight segments. They're not necessarily circles, so you would have to take in those straight segments into account as well. Okay, so let's take another look at an example here. A bike tire has a radius of 15 inches. How far does the bike move when it completes a total of 12 revolutions? Okay, so we're trying to figure out how far it goes when it completes a total of 12 revolutions. So again, 12 revolutions would be how far does the bike move? So again, that's me thinking distance. And then distance moved here. So I guess we're talking about how far the distance is that's being moved. And the phrase distance moved would, again, clue me that this is going to be a circumference problem. Lots of applications for circumference. So I would use the formula circumference is equal to the diameter times pi. But I only know that the radius here is 15 inches. So if I draw in the radius of 15 inches, that means that I can go ahead and draw in a second radius of 15 inches, meaning that the total distance across the diameter is 30 inches. So I know that the diameter is 30 inches. So I'm going to plug that into my formula of circumference is equal to 30 pi, 30 times pi inches. And again, that's my exact answer. So I would take my calculator and I would do 30 times pi, and the circumference would actually be 94.25 inches. So this is how far, this right here, is how far the tire turns per revolution. So if that's the case, I need to multiply by 12 because I'm going to do 12 revolutions. So times 12 revolutions. So I'm going to take 94.25 and multiply it by 12. And I get 1,131 inches as my final answer. And then finally, what is the area of the pizza that this slice was cut from? Okay, so they directly asked me about area here. Now I'm going to go back, as you can see on my wonderfully drawn pizza. 1/8 of the pizza's crust is 6.28 inches. Okay, so crust. I know pizza crust would be the outside of the thing, the outside of the pizza, or the circumference, the perimeter. Outside equals perimeter, which in this case we would call circumference. And so I have 1/8 of the pizza crust. So I have 1 out of 8 pieces of pizza. If I wanted to figure out the entire pizza, so if I wanted to find the entire pizza circumference, I would need to multiply the distance of my slices crust by 8. Because if I take 8 of those, I would have a full pizza. So what I am going to do is say the circumference is equal to 8 times 6.28 inches. And that's because I know that I have 1/8 of it, and the opposite of 1/8, like to make one whole, it would take 8 sections of those. So I'm going to go ahead and type in 8 times 6.28 on my calculator, and I get that the circumference of the pizza is equal to 50.24 inches. Okay, so I then know that circumference is equal to the diameter times pi. So I'm going to write an equation. I'm going to then write the equation that 50.24 is equal to the diameter times pi. So in order to calculate the diameter, I need to divide by pi. So I'm going to take 50.24 and divide it by pi. And the answer that I get when I round properly is that the diameter of my pizza is 16 inches. So I divided both sides by pi. Just want to make that perfectly clear. So I divided both sides by pi, and then the diameter is 16 inches. So I'm going to take my work up here. If the diameter is 16 inches, and I'm trying to calculate the area is r squared times pi. I need the radius. So the radius would be half of that measure, 8 inches. And that is not a good looking 8. We'll fix that. 8 inches. So then I'm going to substitute 8 into my formula. So it would be 8 squared times pi. 8 squared would be 64. So I'd get 64 pi inches. But again, that would be approximate. So I would type 64 times pi into my calculator. And I would get that the area is approximately 201. And I started writing as 64 again. 201.06 inches. So that would be the approximate area of a pizza that the slice comes from. And that's it for today's video, guys. Remember to look at all the different types of problems we can solve with the area and circumference, especially pizza problems, since pizzas are circles and it's a fantastic real-world application. But man, I'm hungry now. Don't forget units, guys, because these are real-world answers. You need to have units. You need to have inches. You need to have meters, centimeters, anything. And then if it doesn't give you a unit, remember that you just need to use units. And if your answers are supposed to be exact or approximate, make sure you're interpreting your answers correctly. If it doesn't say to give an exact answer, because we're dealing with real-world problems, try to give an approximate answer, because that's how you would clearly communicate with most other people. So that's it, guys. That's it for the video. Thanks for watching, and I will see you in the next one.